Let's talk about the sum of a complex number and its conjugate. Here's a question we're exploring. The sum of a complex number and its conjugate is what? Is it A complex, B zero, C real, or D imaginary? To figure this out, we'll follow a simple process. We're going to define a general complex number and its conjugate, then calculate their sum, and finally, we'll determine the nature of the result we get. So, step 1 is defining the numbers. Let's start with a complex number and call it z. A complex number z can always be written in the standard form z equals x plus iy. In this form, x and y are real numbers which we can write as x, y in the set of real numbers. And I is our imaginary unit where I squared equals minus 1. The conjugate of z, which we denote by z bar, is obtained by simply changing the sign of its imaginary part. So z bar equals x minus iy. Now for step 2, let's calculate the sum. The sum, which we'll call s, is z plus z bar. Substituting our definitions, that means s equals x plus iy in parentheses plus x minus iy also in parentheses. Removing the parentheses, s equals x plus iy plus x minus iy. We can group the real parts and the imaginary parts together. S equals x plus x in parentheses plus iy minus iy in parentheses. The imaginary parts cancel out, leaving us with s equals 2x plus 0i. This simplifies nicely to just s equals 2x. Step 3 is determining the nature of this sum. Our sum is s equals 2x. Since we defined x as a real number back in step 1, the product 2x is also a real number. A real number like 2x can actually be expressed as a complex number where the imaginary part is 0. We can write it as 2x equals 2x plus 0i. Finally, step 4. Let's compare our result with the options given in the question. Our sum is 2x, which we've determined is always a real number. Looking at the options, WLOBers, while real numbers are a subset of complex numbers, real is a more specific and accurate description in this case, because the imaginary part is always 0. W, B, 0, the sum is only 0 if our original real part x was 0. It's not 0 for every complex number. X was 0, it's not 0 for every complex number. 2x. D imaginary, the sum 2x has a 0 imaginary part, so it's not an imaginary number unless x is 0, in which case the result is 0, which is real. So, to conclude, the sum of a complex number and its conjugate is always a real number. The final answer is C.